So continuing where we left off, you want to rewrite this as the ordered pair from f of x to the new ordered pair for q of x. Now, I probably should have left a little bit more room than what I just did, but my encouragement to you would be to take this piece and think about how we have a y-axis reflection. So what does that do for the shifting of this piece? Well, if you've been listening to my advice and setting it equal to 0, well, if you subtract 3 over and then divide by -1, you end up with x equaling 3, which is actually shifting right 3. And then this little piece right here, outside means it's up or down, negative means it's down 2. So what I'm getting at is, when you have a y-axis reflection like this, you can actually just leave the order, or excuse me, you can leave this thing that's in parentheses alone. If you notice in a previous problem, let me go back a slide real quick. When I wrote the rule, when it was not a y-axis reflection right here, it was the opposite, left 2. So notice on this problem that what's in parentheses here, because of the y-axis reflection, it stayed the same. Now the y is still shifted down 2, so it's this y minus 2 there. So that should help you as you come up with these answers, just switching colors here. Your negative 3 for your x-coordinate, well, the negative of -3 is positive 3, and when you add 3 to it, your new x-coordinate will be positive 6. Same thing with this one. The negative of -1 is positive 1. When you add 3 to it, you get 4 for your x-coordinate. Plug in the negative of 1 plus 3 is 2. And the negative of 3 plus 3 is 0. And then the negative of 5 plus 3 is -2. And I always encourage students to try this on your own and then watch the video, see if you get it right, and things like that. So now I'm plugging in 5 for y. This is really easy. 5 minus 2 is 3. Plug in 1 for y. Minus 2 is -1. -4 for y. Minus 2 is -6. 1 for y. And then 2 for y. So then we can conclude our ordered pairs for q of x are 6, 3, your x-coordinate, y-coordinate. 4, -1. 2, -6. 0, -1, and this last one, -2, 0. So as we move forward with what are called piecewise functions, I'm not sure how familiar you are with those. These are just fancy conditional statements. So what it's saying is, these are your conditionals. So we only use this graph when x is bigger than -1 and smaller than 4. So if you try to graph this, normally we have arrowheads on either side, like this graph is shifted right 2, down 3, right 2, down 3, and it looks like a parabola. But here's the thing, and remember earlier I talked about if it's a parabola, go up by 1 and then go up by 3. 1, 2, 3, is once you get to x equals 4, which is this value right here, we stop. All right, and we want to go all the way until x is -1. So go up by 1, then go up by 3, and then go up by 5. 1, 2, 3, 4, 5. But you put an open circle here, let me point out, because it does not equal -1. So you want to show the reader that you do not want the value to actually equal that. So you put an open circle right there. So we have a closed circle at x equals 4. We fill it in because it equals right there. And that's it for that piece. That's why we call it piecewise. Then what you do is you switch over to this function for all values greater than 4. Now this is a linear function. Now some students I've actually seen will graph it like it is a linear, where you start at the y-intercept up 2 and then your slope is up 2, right 3, up 2, right 3. but you don't start drawing until you get to the vertical line 4 where x is bigger than that. So you're going to see me continue to draw up to over 3. Up to over 3. I think that's enough points. But you don't actually start drawing the line until you get to x equals 4. And then I've seen a lot of students will go back and erase the dots that they showed the work. I don't always make students erase their dots because you're showing me that you understood what you did to get there. But why did I have an open circle here? Because it's not equal to. Not equal to. So let's look at the next problem where we have all of these pieces. I'm trying to change colors so you can see which piece corresponds to what. And we always go in order, like the top function will be furthest to the left because x is less than -1. So let's think about the absolute value. This is shifted left 2, up 1. So from the origin, left 2, up 1. And it's a upwards v. But once I get to x is -1, that's this value right here, I want an open circle. It's not equal to. And then we have the v shape going infinitely in that direction. I forgot to do this part. I'll go back and do that in a second. Sorry about that. Of stating the domain and range. Now, when we get to x equals -1, we want just the one value, 3. So x is -1. We want this value of 3. And that's it. This is just the ordered pair, like saying when x is -1, y is 3. So then as we get to this, we have another linear. Let me change colors one more time. I haven't used blue yet. So I'm going to do that. This is the linear function shifted up 5. And the slope is down 1, right 2. Down 1, right 2. Down 1, right 2. Down 1, right 2. And just like before, we want to go backwards until we get to that vertical line x is -1. And notice I'm trying to draw an open circle here. That almost looks closed, but there's a little space in there. You can see that graph. Now, as I mentioned, I forgot to state the domain and range. You should have learned in Algebra 2, domain are all the x values. Well, if you look in this problem, the x values, you see how we didn't draw anything to the left of this? So the domain on this problem, we didn't draw anything until we got to x is -1. And when you have an open circle right there, you put a parenthesis because you don't want it to equal -1. And as I go to the right, I have it closed here. I know there's a jump, but there is an x value at x equals 4, and it goes infinitely in that direction. So you draw your infinite sign, and you always draw a parenthesis with infinity. Now, if we talk about the range, those are y values from the bottom to the top. So the first time the range is defined is at x equals -3, but you can see it was a closed dot there, so you put a bracket for the closed dot. And then I know there's a break right here, but there is a y value defined over here. It overlaps. It does go infinitely up. So we go infinitely to the top. So now if we look at this one, the domain, so we read it left to right, because domain are your x values. You see how we have the arrowhead going infinitely in that direction? So it starts from -infinity. Going to the right is x. Yes, there's a jump right here, but x is defined at -1. And it does go infinitely to the right, so we're good there. Now, I always have students confused with this, so feel free to reach out to me if you're confused. The range are the y values. Does it go infinitely down? Well, you might be saying, well, the first time I have it drawn is right here, but we do have this arrowhead. It does go infinitely down. And same reason for the domain, that there's a break in here, but there's a y value defined somewhere, and this arrowhead is going infinitely up. So the range is all reals. That's a fancy way of saying all reals on that. All right, I believe this is my last two problems, and I think I can get this done in time. So as we look at this next one, I've actually seen students draw out these bounds with, let's say, a highlighter, because x equals is a vertical line. I've actually seen students do this. The first time you can draw this first one's from -4 to 0. And then 0. So they kind of break it up in this fashion. If you think of it the same way, I'll do the vertical lines on this one as well. If you have a highlighter, this is not expected of you. between -2 and +1. So they split it up so that they see exactly what they're doing. So in this one, between -4 and 0, we have this y-axis reflection because the negative right here shifted up 3. So instead of starting at 0, 0, it shifted up 3. And it has this y-axis reflection. If I were to plug in -4 in here, the square root of 4 is 2 plus 3 is 5. So -4 goes up to 5. There it is. It's really small on my screen. Sorry if you can see it. Now, there's something wrong with my problem. And you might be looking at it and saying, yeah, I noticed that this is not equal to. So let's fix that. Right here, I should have an open circle right there. So what happens when we get to x equals, this is a closed circle by the way, at x equals 0, we get the y value of 2. There we go. And then this one, for x is greater than 0, it's just a normal square root function, but shifted up 3, so it's right here where we had that open dot. And it goes infinitely in that direction. Let's actually do the domain and range in order here, so I'm not messing this up. So if we look at the domain, left to right, so left, the first time the domain is defined is at -4. And then as we go to the right, yes, there's a hole right here, but there's an x value at 0. So we don't want to show a break right there. And it goes infinitely to the right. So you can say that. Now the range is a little bit trickier because there's not really an interval at y equals 2. I'm not sure if you learned this in Algebra 2, but sometimes we use a brace to say that we have this value, or, and the math symbol we use for or is this union symbol. I don't think you've seen that before, except you may have seen it in Algebra 2. We have this jump up to this value of 3, but I don't want to include it because it's a hole, and it does go infinitely up because of this arrowhead. That's how I like to write my answers. So if you just have one single value, you put it in braces. All right. And I have one more problem, and then you should be set to go for the homework. So I already split it up. This is less than -2, so to the left of this vertical line I drew earlier, you have this y-axis reflection. So it is left 2 if you followed all of my advice, and up 2. So from the origin, left 2, up 2. I have an open circle because it's not equal to. And the y-axis reflection tells me it looks something like that. Okay, not the best drawing because I didn't double check where the points cross, but you can believe me on that one. Let me do a different color for this middle function. This is just a linear function shifted down 2. My slope is down 2 over 1, down 2 over 1, and you can stop right there because that's the vertical line. And you can go backwards as well. You can actually see that they like touch each other right there. And let me go to another color for this bottom one. This is a x-axis reflection, right 1, down 4. Well, that's kind of nice. It just hits right there. But the x-axis reflection shows it's on this side for values being greater than 1. And this is what the graph looks like. Kind of neat, I think. So let's talk about the domain. Well, domain is left to right. It does go infinitely to the left until you get to -2. It does not equal -2, so we put a parenthesis right there, and it jumps on the other side. So that union symbol, which means or, from -2 until we get to 1, because we have a hole right here, or, I'm trying to squeeze it in, 1 to infinity, because it does go infinitely to the right. And then the range, as you notice, these are the y values. It does go infinitely down, and then it stops once we get to -4, that y value. And then from -4 until we get to the y value of 2, right here. And then from 2 to infinity. And now you should be ready to be able to finish the homework.